Now that we have covered exactly how we can obtain the best fit regression line to represent our data, let us now take a further look at how exactly we can use that regression line in order to make predictions on data which will come in the future. Continuing with our rainfall and crop yield example, consider that at this current season, the quantity of rainfall is set to increase. So we currently expect a crop yield of around 30 metric tons, but given the increase in rainfall, we anticipate that the crop yield will also go up. So based on the current predictions, there will be 11 inches of rainfall in this season. Now, these farmers know exactly how much rainfall occurred in the previous season and what the crop yield was for each of them. And given the forecast 11 inches of rainfall in this season, they need to translate that into a crop yield for this year. For example, they know previously that when there were 8.5 inches of rainfall in a particular season, they were able to harvest 20 metric tons of corn. Given the increase in rainfall, it might be reasonable to expect that there is going to be an increase in yield as well. But how much exactly? The first step towards making such a prediction is to plot a regression line against the historical data. And we can use this regression line in order to make a prediction for the crop output for this particular season given the anticipated 11 inches of rainfall. So here we simply draw a vertical line from the value of 11 on the x-axis straight up to our regression line and then map it onto a y value. And this should give us the expected crop yield for this particular season. Of course, there are a few things to be mindful of over here. For one, we need to be sure that there is a cause and effect relationship between rainfall and crop yield. Intuitively, we know that this is in fact the case. However, when using real data sets, one needs to make sure that two factors are not simply correlated or that one just doesn't happen to precede the other. And we also need to make sure that the errors in our dataset fulfill certain conditions. For example, that they have a zero mean and common variance. So now that we have seen how we can make use of a regression model in order to make predictions, let us quickly summarize the steps. First, we ensure that there is a cause and effect relationship between rainfall and the crop yield. Once that was done, we were then able to check the strength of this relationship by plotting our regression line. And if we were to get a line which had a particularly high R square value, for example, then we get a confirmation that there is a very strong relationship between rainfall and crop yield. This relationship has now been quantified by means of a regression line which is represented by an equation. We can then make use of that equation in order to predict the crop yields for any amounts of rainfall. So as the forecast changes to anticipate greater or less rainfall, then we can simply adjust our expected crop output, and the farmers can then use that information in order to plan for the upcoming season.